we're gonna solve from the equation dp dt equals, we're gonna use the form that we already rearranged after we found the critical number. So dp dt equals negative 1 over 4 of 2p minus 3 squared. Okay. As you see, this one is so obvious that this is a separable equation. Okay, separable. So with the separable equation, we're gonna treat them like separate them totally, the p and dp in one side and dt on the other side. Okay, I'm gonna keep negative sign on the right and then take the 4 over just for our convenience. So 4 here divided by 2p minus 3 squared dp equals negative 1 dt. Okay, you can rearrange either way as long as you use the same technique as separable equation. The final solution will be equivalent form. It doesn't look exactly the same, but it's going to be equivalent. No worry about. Okay. So for the antiderivative, the right hand side, yes, we have negative t and then plus c. The left hand side, so just use the use up as u equals 2p minus 3. And this is the integral 4 times 2p minus 3 to the power negative second with respect to p. And from u equals 2p, so du is, this one put arrow, du is 2 dp, okay? Or dp is 1/2 of the du merged with the 2 to be 2 integral u to the negative second du. And this antiderivative will give you negative first divided by negative first, which is negative 2 here. And bring it back in the terms of 2p minus 3. So we get negative 2 divided by 2p minus 3 equals negative t plus c. Okay? This is an implicit solution. And since the what do you call, the p at 0 equals p subscript 0, or the initial population, you either like plug in p at 0 as a p subscript 0 at this step, or rearrange the term to find the solution p in the nice or better looking one. I would go with the current form here to get a c and replace the c with the found term, and then find another form of the solution later. Okay, for this case, as t equals 0, we get c equals negative 2 divided by 2 times p0 minus 3. It just come right out. But yeah, you're gonna deal with the fraction form. It's kind of pros and cons. And then after that, we get the solution in the form of negative 2 over 2p minus 3 equals negative t minus 2 divided by 2p0 minus 3. Okay, another sensitive part that you have to worry about, because you have fraction everywhere, p is hidden in the denominator of the left hand side. So to find the exact, not the exact, the explicit solution, you just have to rearrange the term, and just be careful at this step. So I'm gonna do the technique like make the left and the right as one single fraction. The left hand side is already single fraction, okay, negative 2 divided by 2p minus 3. But the right hand side, I'm gonna combine them into one single fraction. Okay, with the common denominator 2p0 minus 3, and then negative p multiplied by 2p0 minus 3 divided by 2p0 minus 3. So we get negative, if I can add another step just in case if you need more detail, then minus 2. So now we have negative 2tp0 plus 3t minus 2, all divided by 2p0 minus 3. where the left-hand side is negative 2 over 2p minus 3. Okay, it's just be careful because p subscript 0 is some constant number that we don't have it for now. Just have to leave it the way it is. So next, we're gonna do the flip. Okay, like 1 over x equals 1 over y. So that means x equals y. So with this technique, therefore we have 2p minus 3 divided by negative 2 equals 2p0 minus 3 divided by negative 2t p0 plus 3t minus 2. And then we're going to clean up solving for p. The p is one single term on the left hand side there. Cut a pivot off one layer at a time. Oops, where did it go? All right. Multiply all by negative 2. So get 2p minus 3 equals negative 2 here. I think we can go ahead and multiply by negative 2 to be negative 4 p0 plus 6, okay, divided by negative 2t plus p0 plus 3t minus 2, and then plus 3 both sides, added by 3 both sides. And then we get 2p equals negative 4 p0 plus 6 divided by negative 2t plus p0. No, this is 2t. Yeah, see, I already make a mistake. Hang on a second. Since we flip this bottom is negative 2t p0 plus 3t minus 2. p0 plus 3t minus 2. And then since we add by 3, okay, same denominator. Something that I have to work to be careful. So divide multiply 3 with the same denominator. It's gonna be plus the 3 times negative 2tp0, which is negative 6 tp0 plus 9t minus 6 minus 6. And you see 6 and 6 cancel. Okay. And then your p equals 1/2. And actually the numerator here is negative 4 p0 minus 6 t p0 plus 9t. And then we divide all by 2. After we divide all by 2, the top, which is negative 4 p0 minus 6 t p0 plus 9t divided by 2 will be on the bottom here, negative 2t. I can multiply all by 2 or leave it as the factor 2 in front of the parentheses. Okay, so this is the general solution. If we know p subscript 0, we can plug it in and get the particular solution for this solution p. All right, it's not pretty, right? It's not pretty. Now we're gonna question for part B, find the analytical solution. The technique always the same, but the detail depends on how much algebra that you have to deal with. Okay. No question. Next, we're gonna do the last part, which is find whether the P becomes 0 or not. If it can become 0 or population will die out or will be 0, we're gonna find what would be that point of time. So I'm gonna add another page. Okay. So part C, from p equals, I'm going to copy it down, negative 4p0 minus 6t p0 plus 9t all divided by 2 negative 2t p0 plus 3t minus 2. And then the question is, can p be 0? Okay, if we look at this case, so that means when you have the fraction and let it be 0, we just ignore the denominator. We just set it up negative 4 p0 minus 6t p0 plus 9t equals 0. Just let the numerator become 0 because denominator will never be 0 anyway. Otherwise, it's going to be undefined. Now we're going to find out, can we find the t, the making sense t, or the t, the way that is it making sense is the way that can t be positive number that make t to be 0. Okay, we're gonna find out by solving for t for this expression. Okay, to solve for t, you can see that we have two terms containing t, and keep these two terms and move negative 4p0 to the other side, and at the same time we factor the t out for these two terms, so you get negative 6p0 plus 9 equals 4p0. Okay, that means t equals 4p0 divided by negative 6p0 plus 9. Now we get the expression for the t. For the p equals 0, is that possible? We have to make sure that t is greater than or equal to 0. And since p subscript 0, it has to be some initial population. Okay, so p is not 0, and at the same time p subscript 0 greater than 0. Okay, that means we just ignore the equal symbol here. So we're gonna look at the case, the inequality p 4p0 over negative 6p0 plus 9 greater than 0. When you analyze it, you don't have to solve like back and forth, back and forth. What you would do, in this case, the bottom here, the p subscript 0 is already greater than 0 or already positive. So that means we're gonna make negative 6p0 plus 9 to be positive for the condition that make the t positive quantity that will reflect to the p or the population to be 0. So for the case that we can find the point of the time, the p subscript 0 has to be less than 9 over 6 or less than 3 over 2. So the initial population has to be below 3 over 2. And eventually the population will approach 0. And which go along with the phase portrait that we did. As you see, let me go back to the part A. From the phase portrait, the initial population above 3.5, so it will approach the 3 over 2. If initial population between 0 and 3 over 2, since the population is decreasing, eventually it's gonna hit the point of time that the population will become 0. Okay, so with this one kind of, we did in the analytical way. Since we don't have the actual number to work on like in the normal equation form, so this case, so we kind of figured out the condition that make the population become 0. For the case that the initial population has to be less than 3 over 2. And the following part of it. So what would be that point of time t? So the point of time t, so you just go back to replace it into the equation for the t.